Hello all, welcome to CS 470 Project 2 Conference Presentation Cloud Development. My name is Veronica Guzman. I'm a senior at Southern New Hampshire University, currently pursuing my bachelor's degree in computer science. Today I'll be discussing cloud development, breaking down its key concepts and explaining its significance in modern technology. The goal of this presentation is to bridge the gap between technical and non-technical audiences, ensuring that everyone can grasp the fundamentals, benefits, and real-world applications of cloud computing. Let's dive in. Cloud migration and containerization. Cloud migration models, cloud to cloud, move applications between providers with minimal changes, rehosting, lift and shift, migrate as is with little modification, refactoring, optimize for cloud native features for enhanced performance, replatforming, make minor adjustments for better cloud compatibility, containerization tools. AWS provides cloud infrastructure for deployment, Docker packages applications for consistent portable execution. Docker Compose manages multi-container applications efficiently. Using these strategies and tools ensures scalable, efficient, and flexible cloud applications. Docker Compose and orchestration. Docker Compose simplifies managing multi-container applications with a single YAML file to define services like databases, API, and front ends, automate networking between containers, manage environment variables and dependencies. This ensures consistent, efficient, and scalable deployments across environments. Serverless computing and cloud storage. Serverless computing, a cloud model where providers manage infrastructure, letting developers focus on code. Advantages: no server management, no manual provisioning or maintenance. Scalability, auto scales with demand. Cost efficient, pay only for resources used. Faster deployment, reduces operational overhead. Amazon S3 versus local storage. Amazon is a scalable cloud-based object storage service. Comparison. Scalability, S3 is virtually unlimited. Local storage is hardware bound. Accessibility, S3 is globally accessible. Local storage is device restricted. Durability and backup, S3 has built-in redundancies. Local storage needs manual backups. Cost, S3 is pay-as-you-go. Local storage requires upfront investment. Leveraging serverless computing and cloud storage enhances efficiency, scalability, and cost savings. Serverless APIs and AWS Lambda. Advantage of serverless APIs. Automatic scaling, adjust resources based on demand, cost efficient, pay only for execution time, faster development, no infrastructure management, high availability, ensured uptime with AWS, event-driven, functions run only when triggered. How AWS Lambda powers serverless APIs. Event-driven execution, runs in response to API requests, stateless processing, each function runs in isolation, AWS integration connects with S3, DynamoDB, etc. Triggered via API gateway, routes HTTP requests to Lambda. Key components for implementation. Lambda function code, backend logic in Python, Node.js, etc. API gateway configuration defines routes and integrations. IAM roles and policies, manages AWS service permissions, infrastructure as code, automates deployment with CloudFormation, Terraform. Front-end, back-end integration steps. Step 1, configure API gateway for endpoints. Step 2, develop and deploy Lambda functions. Step 3, enable cores for front-end access. Step 4, set up authentication AWS Cognito/IAM. Step 5, connect front end via HTTP request. Step 6, test API responses. Step 7, deploy and monitor with AWS CloudWatch. Using AWS Lambda for serverless APIs ensures a scalable, cost-effective, and high-available backend. Databases and serverless cloud apps, MongoDB versus DynamoDB. Key differences. MongoDB, document-based, NoSQL, stores data in Bison, supports flexible schemas and indexing. DynamoDB, AWS managed key valued/document stores, use partition and sort keys, auto scales, common queries. MongoDB, find, aggregation, CRUD. DynamoDB, get item, query by partition key, scan all items, not recommended for large data sets. Required scripts, database connections, MongoDB, Mongoose, Node.js, PyMongo, Python, DynamoDB, AWS, SDK, Boto3 for Python, Node.js, SDK. CRUD operations, efficient data handling for both databases, indexing and optimization. MongoDB uses create index for faster queries. DynamoDB uses global secondary index, GSI. Infrastructure as code. DynamoDB managed via Terraform, AWS, CloudFormation. MongoDB deployed using Docker Compose/Kubernetes. Understanding these database models, queries, and automation scripts ensures efficient scaling in serverless cloud applications. Cloud computing offers key advantages that make applications scalable, efficient, and cost-effective. Two core principles that enable this are elasticity and the pay-for-use model. Elasticity ensures that applications can scale automatically to handle varying workloads. Autoscaling adjusts resources dynamically based on demand. High availability keeps applications responsive even during traffic spikes. Efficient resources utilization prevents over-provisioning by scaling resources needed. Cost-effective scales down when demand is low, reducing unnecessary costs. Pay-for-use model. The cloud operates on a pay-as-you-go pricing structure, optimizing costs for businesses. Cost efficiency. Pay only for the computing power, storage, or bandwidth used. No upfront cost. Eliminates the need to purchase and maintain physical infrastructure. Optimized billing. Charges vary based on the actual resources usage, preventing waste. Scalability without extra cost supports business growth without overspending on unused capacity. By leveraging elasticity and pay-for-use models, organizations can build scalable, cost-efficient, and high-performing cloud applications. Cloud security best practices, authentication, authorization. Use OAuth, JWT, or AWS Cognito for secure login. Implement role-based access control, RBAC, to limit permissions. Encryption. Encrypt data at rest, AES 256, and in transit, TLS, SSL. Access control. Define IAM rules and policies for AWS services. Use firewall and security groups to restrict access. API security. Secure APIs with AWS IAM or API keys. Enable rate limiting and input validation. Network security. Use VPCs, VPNs, and private subnets for isolation. Implement Zero Trust Architect ZTA. Monitor and auditing. Track activity with AWS CloudWatch, MongoDB Atlas. Set up alerts for suspicious behaviors. Regular updates and testing. Apply patches and conduct security audits regularly. Implementing these measures protects cloud applications from threats, unauthorized access, and data breaches. Managing roles and policies for cloud security. Roles and policies overview. Roles define permissions assigned to users, apps, or services. Policies set rules, specify allowed or denied actions. Rules use policies. Multiple policies determine access levels. AWS IAM example. Roles can grant access to S3, DynamoDB, Lambda, etc. Custom IAM policies. Read only, view data, no modifications. Admin, full resource management. Restricted API access. Limits endpoints access. Logging and monitoring. Access to CloudWatch logs. Least privilege. Grants only necessary permissions. Well-structured roles and policies ensure secure, controlled access in cloud applications. Securing cloud connections, Lambda, and API gateway security. IAM authentication, restrict access with roles and policies. API keys/OAuth, validate requests securely. HTTPS, TLS/SSL, encrypt all API traffic. Rate limiting, prevent abuse with request limits. AWS WAF, protect against SQL injections and attacks. Lambda and database security. VPC isolation, place databases in private subnets. IAM-based authentication, avoid static credentials. TLS/SSL encryption, secure data in transit. Restricted access, only allow authorized Lambda functions. AWS secrets manager, securely store credentials. S3 bucket security, bucket policies and IAM rules, restrict access. S3 encryption, use SSE S3 or SSE KMS. Block public access, ensure data privacy. Enabling versioning, protect against accidental deletion. AWS CloudTrail monitoring, track access, and detect threats. These measures ensure API, database, and storage security in cloud applications. Key takeaways for effective cloud development. Security and access control. Use IAM rules, encryption, and network security to protect resources. Secure connections with VPCs, TLCs, and restricted permissions. Scalability and serverless architecture. AWS, Lambda, API gateways, and DynamoDB enable scalable, event-driven applications. Autoscaling and pay-per-use pricing. Optimize performance and cost. Infrastructure as code and automation. Terraform and CloudFormation streamline resource deployment. CI/CD pipelines, CloudWatch, and GuardDuty automate security and monitoring. By focusing on security and scalability and automation, you can build efficient and resilient cloud applications. Thank you all for your attention and time today. I hope this presentation provided valuable insights into cloud development and its key principles. If you have any questions or would like to discuss any points further, feel free to reach out. I look forward to continuing this conversation.